This is question number 20. The figure below is an equilateral ABCD, which AB is 8, BC is 6, CD is equals to AD, and angle ABC, angle ABC is equals to 70, and we have angle ADC is 50. So that information is given on the diagram that we have. So this is our quadrilateral. It looks like a kite, but the difference is that this side is not equal to that. So we look at the questions required for us to do. Calculate correct one decimal place the length of AC. This is our AC. We can use a line there to denote the AC. So that is our AC, the line that we are required to find the length. Now, looking at triangle ABC, we can be able to use the cosine rule to be able to find AC. So we can say AC, let's use this color here. We say AC squared is equals to AC squared is equals to AB squared. AB squared. Okay, we can have the formula first. Plus BC squared minus 2. Instead of doing that, I would rather use small letters. So we can say this is A, this is our C, and this is our B. So where our B is the AC. So we can say B squared is equals to A squared plus C squared minus 2 AC, the cosine of that is the cosine of B, which we can be able to now be able to substitute. Our A is 6 squared plus our C is 8 squared minus 2 multiplied by 6 times 8, the cosine of 70. And then you can use your calculator here and say 6 squared is 36. Then we say plus 8 squared is 64. Then you minus 2 multiplied by 6 multiplied by 8, the cosine of 70, and that is giving me I'm getting let me check that. I'm getting 67 is equals to 67.166. So I can say 67.17 to 2 decimal places. We are told to 1 decimal place, so we can talk of 1 decimal place, and it is since I'm getting 67.16, so we can say 67.2. That is B squared, implying that B squared is equals to the square root of 67.2, which is equals to so it's get the square root of that, and I'm getting 8.195. So to 1 decimal place, I'll say it is 8.2. So this is 8.2 centimeter. So that's how you get the AB. We are supposed to get the length DC. DC, this is this side. What we do is you note that angle ADC is an isosceles triangle. So if you drop a perpendicular here, it will divide this angle into 2. So this becomes now we get this is 25 degrees and this is 25 degrees. This side becomes 44.1 and this is 4.1. We divide 8.2 by 2. We can use the trig ratios and say to get this angle, this is 90. So we say to get, and we are getting that is DC. So we can use a sign. We say the sine of 25 is equals to the opposite, which is 4.1. You divide by the hypotenuse, which is DC. This implies that DC is equals to 4.1 divided by the sine of 25. You can do that using your calculator and say this is 4.1. You divide by the sine of 25. I'm getting 9.7. 9.7, and that is, I'm getting 9.7014, and we are told to work to 1 decimal place is equals to, so we get it is 9.7 centimeters. You'll be able to get 2 marks there. We look at part 3, size, the size of angle BAD. Where is that angle? BAD is this angle. BAD, that angle. That angle, because we know this is, already we know this angle is 25. So this angle is 50. So the base angle is this angle is 65, and this is 65 degrees. So that is it 65? That should be so that we get 130 plus 50. They add up to 110. That's correct. So what we need is this angle, so that we add to 65 to be able to get the whole of this angle. Now, how do we get that? We use the sine rule. We have 6 here and theta, and we have 8 here. We have 8.2 and 70. So we say we are looking at that is we say this is 8.2 divided by the sine of 70 degrees is equals to, now we say it is 6 divided by the sine of theta. So we can now say this implies that sine theta, we cross multiply, is equals to 6, the sine of 70, you divide by 8.2. This is 6, and you can use your calculator to get sine theta. So we get 6 multiplied by the sine of 70, and that is equals to what? 5.6. You divide by 8.2, and I'm getting 0 point is equals to 0.68. To 4 decimal place, I'm getting 76. So once you get there, then you say sine inverse of 0.6876 is equals to, you can use a calculator. You press inverse, you press sine, that will give you sine inverse of the answer, and that I'm getting 43.438 to 1 decimal place should be 43.4. So this angle here, again, we have 43.4. So now we should be able to get BAD. That is BAD is equals to 65 plus 43.4, and that will give you 43 is equals to, I'll be able to get, this is plus 65, that is giving me 108.4, 108.4 degrees. So that is 108.4. I hope that is clear. So that's how you get a triangle, that is angle BAD, this angle, the whole of this angle. So what we needed is to calculate the size of this angle theta. We add to 65, and we will be able to get the size of this angle. We look at part B. Calculate the area of the quadrilateral ABCD to 1 decimal place. So how do we get the area? We can get the area by you get okay, we can get the area by getting the area of triangle ABC. Area is equals to area area of ABC. Area of ABC, we can use a half multiply a half AB, that is 6 times 8, the sine of 70, and now the other one we can, and we add that this other one ADC, we can use a half base times half. Do we have the height? We don't have the height, so we have this angle. So what do we have here? We have base times height. We can get the height. We can get the height somewhere here. There's now the height is equals to, we get a half base. We can, okay, let's see. This is the height. If we have this side and we have the angle, so we can get, we can use a cosine. The cosine of 25 is a adjacent over, or you use a tangent. Let's use a tangent to be able to do that. The tangent, this is the tangent. Let's use that. So we use a tangent to be, so we can say the tangent of 25, that is the angle 25, is equals to opposite over adjacent, that is opposite is 4.1 divided by excuse me, now the height. So we can get the height is equals to 4.1, you divide by tan 25 is equals to, use your calculator, we can get 4.1 divided by the tangent of 25, and that is giving me 8 point, it's giving me 8 point, I think here we already have there is some information here I have not included. We don't need to do that. Remember, in this part we have found DC. This side here it is 9.7 and this side here is 9.7. So that's what we can, that is a bit simpler. So we just say it is a half AB, which is 9.7 multiplied by 9.7, the sine of 50. That will be easier for us. So this is equals to, you get 24 multiplied by the sine of 70, and that gives us what? That gives us 22.55, so it is 22.6, and then we add 0.5 multiplied by 9.7 multiplied by 9.7, the sine of 50 is equals to minus 2.6, and that is giving us 35.99. So to one decimal place, then we say it is equals to 36. Then this is 36. So that is giving me, so we say 22.6, you add to 36, and I'm getting 58.6. 58 point, let's write it properly, 58.6. So that is the area. This is centimeter squared. That is the area of the quadrilateral ABCD. Now, what do you say about this question? First of all, here you need to know some of the properties of triangles, and here we have applied both the cosine rule and the sine rule. So you need a mastery of that. Again, you need to know, to remember how to find the area of a triangle. So generally this is this what is being tested here is whether you remember the cosine rule. Remember, if you don't remember the cosine rule, there is no way you can be able to get the length of AC unless you use it, because you are given two sides and inclusive angle. So that is very important. Although you still find it in the mathematical table, but it is good to master these rules. Here we have the sine rule. It is easier for us to use it because you see here we have the triangle here is ABC, is an isosceles triangle. It is easier to use the side that is no, this one easier. Here we need to get this angle, so the sine rule would help us to get this angle theta, and then we will be able to add with the angle here. Remember, also you need to remember that the base angles of an isosceles triangle are equal, so that you are able to get 65. And finally, finding the area of a triangle. So that's all. That's the few things I can note about this question. But I hope you have followed, and you should be able to apply that in other questions that you may come across in future. Question number 21, we are told solve for x. So we have x into bracket x minus 4 squared is equals to into bracket x minus 8 close the bracket into bracket 2x plus 7. So to solve for this, we need to expand, and once we expand, you'll be able to get a quadratic equation and you can solve. So this is we can write it as x minus 4. We have x minus 4, that is what it means, is equals to then we have, you expand this is x multiplied by 2x, that is 2x squared. Then we have x multiplied by 7, that is plus 7x. Then minus 8 times 2x, that is minus 16x. Then minus 8 times 7, that is minus 56. That is minus 56. We also do the same here. So here we have x squared times 4x minus x multiplied by minus 4 is minus 4, and minus 4 times x is minus 4. Those that gives us 8x. Then we have minus 4 times minus 4, that is minus 16, is equals to 2x squared. This is 7x and minus 16x, that will give us minus 9x minus 56. So with that, we bring all this to the other side. For example, x squared, you take it to the other side, becomes negative. So we have 2x squared minus x, we will be left with x squared. 8x crosses the other side, it becomes positive. So minus 9x plus 8x, that will give us minus x. 16, once it crosses the other side, then we should be able to get positive. That is positive. And once you get positive to the other side, you take it to the other side, it becomes negative. And once it gets negative, now this is supposed to be positive there, so it will be 56 minus 56 plus 16. That's why I'm confusing. So that will be minus 72. Minus 72 is equal to 0. So this is a quadratic equation, and you can solve it using the factor method, and say this is x squared minus 9x plus 8x minus 72 is equals to 0. You get to this two, we have just modified. Minus 9 multiplied by 8 will give us 72, and minus 9 plus positive 8, it is minus 1. So we factor out x, that should be simple, 9, and then we factor out 8, we'll be left with x minus 9 is equals to 0. So x plus 8, close the bracket, and x minus 9 is equals to 0. So either, we normally say either x plus 8 is equals to 0 or x minus 9 is equals to 0, because when you multiply two numbers you get 0, then one of the numbers must be 0 or both are 0. So we say x is equals to minus 8 or 9. So that's how you solve that. So by doing that, you'll be able to get 4 marks. Part B, John cycled 6 kilometers from his home to school at an average speed of 2x minus 3 kilometers per hour. Peter walked 2.4 kilometers from his home to the school at an average speed of x kilometers per hour. Peter took 16 minutes less than John. Determine the time in minutes that John took to reach the school. Now, time, we normally say time is equals to a distance over speed. So for time taken by John, we are told Peter took less than 16 minutes to less than John. So John, it means time taken by John is 6 divided by the speed, which is 2x minus 3. So that is if you subtract the time taken by this is for John by Peter, which is 2.4, you divide by the speed, which is x, that should give you 16. But 16 is in minutes, but our speed is kilometers per hour. So you divide by 60 to be able to convert to hours. That is 16 minutes to hours. So what we can do here is we can divide by 4. You get it is 4. By 4 it is 15. With that, then we come and say we cross multiply here. We get 6x minus 2.4 into bracket 2x minus 3. All this is divided by 2x minus 3, and you multiply by x is equals to 4 divided by 15. We open the bracket here and say this is 6x minus, this is 2.4 multiplied by 2x, that is 4.8x minus, you multiply here, minus 3, 2.4 multiplied by minus 3, that will be plus 7.2. You divide by, this is 2x squared minus 3x is equals to 4 divided by 15. You cross multiply again, so this is 15. When you subtract here 6 multiplied by 4.8, that you minus, this is 2, this is 1.2, so it is 1.2x plus 7.2 is equals to 4 multiplied by 2x squared minus 3x. So you open the bracket now, and you will be able to get, let's see, 15 we multiply by, let's see, 15 you multiply, okay, we multiply by 1.2, and you get it is 18. So you get 18x, then you have 15 multiplied by 7.2, and that should give you 108. So that is plus 108 is equals to 8x squared minus 12x. Put the right terms together, so you have 8x squared. Then you take 18x, that will be minus 30x minus 108 is equals to 0. That's a quadratic equation. So we need to solve this quadratic equation. Let's see, we can divide by 2 here. We get 4x squared minus 15x minus 54 is equals to 0. So what we do here is it is a quadratic equation. Let's multiply 4 times 54. 54 times 4, that is 216. 216, we can get the factors of 216. 216 by 2 you get 108. By 2 you get 54. By 2 you get by 2 you get 27. By 3 you get 9. By 3 you get 3. So if we check this, we can multiply. Let's take 9. This is 2 times 2 times 2, that is 8. 8 multiplied by 3, that is 24. So if you take 24 and 9, that should be able to help us. So we can now say 4x squared. This will give us 24x plus 9x. When you multiply the 2, you get 216. 54 is equals to 0. When you are using the factor method, it is easier as long as you'll be able to get the factors, that is to modify your equation in such a way that when you multiply this number 24 times 9, you get the product of 4 times 54, which we have found it is 216, and when you add them you get the coefficient of x. So we can factor out 4 here, that is 4x. Once you factor 4x, you'll be left with x minus 6. Then we have plus. Here we can factor out 9. You'll be left with x minus 6 is equals to 0. So here we have 4x plus 9, and we say this is x minus 6 is equals to 0. So x is equals to minus 9 over 4, or we have x is equals to 6. Because x represent actually x represent a value, then we ignore the minus sign, the minus value. So we say our x is equals to 6. So once you get x is equals to 6, the question is determine the time in minutes that John took to reach the school. So we can now come and say the time John took to reach the school. Remember, time for John, that is John. So we say time is equals to John took 6 divided by, we have found that x is equals to 6. So 12 minus 3 is 9 is equals to, you simplify here, by 3 is 2, by 3 is 3, is equals to 2/3 an hour. And we are told to present our answer in terms of minutes. So it means time is equals to 2/3 of an hour. That should give us that is equals to 40 minutes. So it means that time taken by John to reach the school is equals to 40 minutes, and that brings us to the end of that question. So you look at this here, the knowledge that you are being tested is whether you know how to solve quadratic or application of quadratic equations. Do you know how to solve the quadratic equations? Remember, we have four methods of solving a quadratic equation. The easiest and the easiest one is a factorization method. The second one is completing the square method. The third one is using quadratic formula. The fourth one is using the graph. But you use a graph method only when you are given a graph, or you specifically. If you are given a question, a quadratic equation, or if you are working on a question, application of a quadratic equation, the first thing you check when solving a quadratic equation is whether the equation is, you can use a factorization method, because it is the easiest and the fastest. If you can't, check the quadratic formula. That is better, also faster. That is after, if you find an equation is not solvable by a factorization method. You use complete the square method only when it is specified that you use that particular method to solve the quadratic equation. Then when you are given a graph and you solve to solve quadratic equation, then you should be able to use a graph or the grid to solve that. So that's what I can say about that question. If you are comfortable with solving quadratic equation, then this question should be easy for you. So that's how you do that question. Question number 22. The position vectors A and B are -4, 6 and -8, 2 respectively. Point M is a midpoint of AB and point N is a midpoint of OA. Part A, find Roman number 1, the vector AB. Before we start answering the question, it is good that we have a sketch of the information we represented on a sketch. So we can say that is our vector AB. So this is that is the origin. So we have this is our A and this is our B. The coordinates of A are -4, 6 from the position vector here, and the coordinates of B are -8, 2. This is the origin, so that is the direction of that vector. M is a point here, M the midpoint of AB, N is the midpoint of OA, so we have our N there. So that is the information that we have been given here. So to find AB in vectors, we say to move, it is right to move from A to B using an alternative route. So we say we move from A to O and O to B. So we say, but instead of saying AO, we say minus OA, where minus represents that you are moving against the direction of the vector. So we say AB is equals to minus OA plus OB, which we can rewrite it as OB minus OA, and we have our OB is -8. We have been given here the position vector, means the vector from the origin. So it is -8 and 2, and we have minus. The other one is -4 and 6. So this is equals to -8 minus -4, that is -8 plus 4, and that should give you -4. This is 2 minus 6, you'll be able to get -4. So that is a vector AB, which we have been asked to find. Roman number 2, what we do is the coordinates of point MN. So we can get the coordinates of M. Let's start with M. We can use the coordinates. So we can say -4 minus 8, that is -4 plus -8, you divide by 2, and the y is 6 plus 2, and you divide by 2, so this will give you m. This is minus 12 divided by 2, that is minus 6, and this is 8 divided by 2, you get 4. So these are the coordinates. That is the simplest way you can get the coordinates of m. N is a midpoint of OA, so you can just do the same and say n. The coordinates at the origin is 0, 0, so you just say it is minus 4 plus 0 divided by 2, and we have we have the other one is 6 plus 0 divided by 2, and this should give you n is this is minus 4 divided by 2, that is minus 2, and the other one is 3. 6 divided by 2, you should be able to get 2, 3. So that is, you'll be able to get a mark for each. The magnitude of nm, the vector nm, this is the vector nm, that's okay, nm, so that is the vector nm. How do you get the magnitude? We need first of all to get the vector nm. Nm is equals to, you can say it is minus on, minus on plus om. We can put om here. So remember, we have already obtained the coordinates of m and n. So our m is we have found it is minus 6 and 4, and our n we have found it is minus 2 and 3. So getting these vectors is easy. So this is equals to om minus on, which we can get, and just use the same. Our om is minus 6 4, you minus on is minus 2 3, and this you will be able to get as minus 6 minus 2 is minus 6 plus 2, and that should give you minus 4. This is 4 minus 3, that will give you 1. So that is our om, that is our nm. And to get the magnitude of nm, we say nm is equals to the square root of minus 4 squared plus 1 squared, which you get, this is the square root of 9, and that should give not let's see, not 9, but this is 16, square root of 17. So when you get the square root of 17, then you should be able to get the square root of 17 using a calculator. It is equals to 4.12, then this is to 2 decimal places. So that's how you get the magnitude of nm. Part B, we are told the coordinates of point C is 2a, 2a. That is 2, x is 2, and y is 2a. Vector CA is parallel to vector OB. Determine the value of A. The first thing is we can be able to show that vector. So we can say this is where we have our C, and the coordinates are coordinates of C. This is C, coordinates of 2 and A. So this is vector C. It is parallel to OB, so that is important. With that, you can come here and say two parallel vectors. Let's first of all find CA. We say CA is equals to, from C we can draw another vector here to represent vector OC. So this is OC. So with that, we can say CA is minus OC plus OA, which we can write it is OA minus OC. So we already have the coordinates of A, or with that we have the position vector OA. So this is equals to minus 4, this vector here, and 6, and then we subtract OC. OC will take the position vector with the coordinates 2 and A. So this is 2 and that is A. So this will give us minus 4 minus 2, that will give us minus 6, and this is 6 minus A, so we just write 6 minus A because we don't know A. That's what we are looking for. Now that is our AC, and because we are told that CA is parallel to OB, it means we can be able to express OC in terms of OB. Not OC, rather it is not OC but CA. CA is a scalar multiple of OB because they are parallel. Now we already have OC, so we have minus 6 and 6 minus A. That is what we have found to be our CA. Once we have that, it is equals to K. Our OB we already have, it is minus 8 and 2. So with that, we can now equate K minus 6 is equals to minus 8K, because they are the same. So we can say our K is equals to, you divide both by minus 8, it is 6 minus 8, that is minus 6 minus 8, which is equals to, you divide by 2, it is 3 quarter. So that is the value of K. With that, we can again now equate. So it means 6 minus A is equals to 2 multiplied by now 2K, but now we already have our 2K, which is 3 over 4. We can simplify here. By 2 is 2, by 2 is 1. So 6 minus A is equals to, this is 3 over 2. That is 3 over 2. Once you get that, you can take A to the other side and have this. So this is A is equals to, let's use this part. A is equals to, this is 3, no, that is 4, sorry, this is 2. A is equals to 6 minus 3 over 2. So A is equals to, 3 over 2 is the same as 1.5. So this will be 4.5. A is 4.5. Or A is equals to 9 over 2. So that is the value of A, which we are supposed to find. So that's how you work out that. So you are taught vectors 2 in form 3. This is where this is a question where you need to apply that knowledge. So if you look at section 1, you need to know what are position vectors. These are vectors that are from the origin, but you need to know how to find the midpoint of the coordinates of midpoint. This one you learned in form 2. This one you need to know. You also learned in form 2 how to get the magnitude of a vector. That if you are given that if a vector is x and y, the magnitude is equals to the magnitude of the vector is actually the square root of x squared plus y squared. That is how you get the magnitude. So from there, then you have part B. Then this you need to relate the parallel vectors and know that for parallel vectors you can express one vector as a scalar multiple of the other, and that is a concept that we have used here to be able to arrive to the answer here, which is 9 over 2 or 4.5. So that's how you approach that question.